So he said there is an array of 8 aluminum alloy fins, each 3 millimeter wide, 0.4 millimeter thick, and 40 millimeter tall. And so there are 40. Here's my pen. And so there are 8 of them sitting next to each other. They are sitting on a transistor. So you could actually think that so they are sitting on a transistor, and there are, say, 8 of them. So there is 8 of those guys, right? All of them are basically same dimension. And the idea, of course, is you would like to increase the Q leaving this guy by increasing the surface area. Alright? So what does he want? He gave us the temperature of the base, T base, and the temperature of the he gave us the temperature of the base and the temperature of the air, and he gave us the K and the H. Alright? And of course the dimension. And he basically want to find out how much power do they dissipate if the combined convection and radiation heat transfer coefficient is 8 kilowatt per meter square Kelvin. So when we saw this before, when you say the combined convection and radiation, he's basically lumping the heat transfer by radiation into the convection. He's basically treating it as just increased H. The H is some of it, some of this 8, say 7.5 is convection and 0.5 is radiation. Alright? So we just treat it as convection, basically. Alright, so he would like to get the Q from them. And we know those fins can be treated 4 different ways, depending on the assumption you assume. Very long, insulated tip, convection from the tip, all those things. And he said in this case, he said that the heat loss from the fin tip can be assumed negligible. Alright? So you just open the fin section in the textbook and you find out the Q for insulated tip. And it has this multiplied by 10 ml. And why that's multiplied by 8? Because there are 8 of them. And what are those terms? H, that's the convection heat transfer coefficient. P, that's the perimeter. That's basically going all over the cross section, counting the width and the height and the width and right. So 3 and 4, and the cross section area. And finally, that M is HP over KAC. So you calculate those right, you get 1.5. You put this formula right, that's 2. This guy is worth 1 point, and then the final answer is 0.5. Question about this?